Good day, one and all. Myself, Akshata, and I welcome all the students to my channel named Tutor Akshata. I hold a degree in civil engineering and a master's degree in foundation engineering and have over 10 years experience in teaching in government as well as in private engineering college. I have started this channel where I will be teaching various courses related to civil engineering as well as certain other courses. The first course that I will be engaging is the course on engineering mechanics, where I will be covering various topics under engineering mechanics, such as topic on resolution of forces, finding resultant, friction, centroid, moment of inertia, etc. So let us start with this course on engineering mechanics. To understand what is engineering mechanics, let us first start by understanding what is mechanics, and then let us see what is engineering mechanics.
Mechanics is a branch of science that describes and predicts the effects of forces on objects that may be under the state of rest or in motion. So in mechanics, what we will be doing is we will be studying the effect of a single force or multiple forces on objects or bodies, and that object may be either in the state of rest or in motion. When we are talking about mechanics as a branch of science, the specific branch of science here is physics. Now, mechanics can be classified further based on the type of body the forces are acting. Now, the forces can be acting on rigid body or elastic body, or the force can act on fluid. So, based on the type of body the force is acting, you can classify mechanics as undeformable body mechanics, deformable body mechanics, and fluid mechanics. So, let us see what each of this is. So let us start with undeformable body mechanics. Now what do you mean by undeformable body mechanics is when the forces are acting on rigid body. The study of forces acting on rigid body is called as undeformable body mechanics, or it is also called as rigid body mechanics. Now you may ask me, what do you mean by a rigid body? Rigid body is the type of body which under the application of forces does not change in its shape, size or structure. So under the application of forces, the size, shape, structure of the body remains same, then that particular body will be called as a rigid body. So study of forces acting on rigid body is called as undeformable body mechanics, or it is also called as rigid body mechanics, and the specific term that we will be using throughout for study of forces acting on rigid body is engineering mechanics. Next, let us see what is deformable body mechanics. If the forces now are acting on deformable body or elastic body. So now what do you mean by a deformable body is under the application of force, the body is changing in shape, size, structure. Okay. So if the forces are acting now on deformable body, then the study of forces acting on deformable body will be termed as deformable body mechanics, and finally if the forces now are acting on fluid. Now the fluid could be either a liquid, gas, etc. So the study of forces acting on fluid is termed as fluid mechanics. Now students of civil engineering and mechanical engineering will be studying in detail about deformable body mechanics and fluid mechanics in their higher semesters. At the first year level, we will be restricting ourselves only to study of forces acting on rigid body, that is, we will be restricting ourselves to rigid body mechanics or specifically engineering mechanics. Okay, so let us see now how engineering mechanics is further classified into. So I'll just again redefine what is engineering mechanics. Engineering mechanics is the branch of mechanics which deals with study of rigid bodies under the application of forces. Now, the forces acting on the rigid body can cause the body to be at rest or the body may be in motion. So, study of forces acting on the rigid body and the body is at rest is termed as statics, and study of forces acting on rigid body and the body is moving is termed as dynamics. Now dynamics again can be classified into kinematics and kinetics. Now what exactly is kinematics is, consider a body which is subjected to some external force, and because of the external force the body is undergoing certain acceleration, it is undergoing certain displacement, right? So if I am studying only the effects on the body caused by the force, that is, I am studying only about, say, the speed of the body or acceleration of the body or the displacement of the body, then it will be termed as kinematics. I am not considering the force which is causing the motion. Okay, that study will be called as kinematics. And what is kinetics? If I am considering the force which is causing the motion of the body along with the effects on the body, I am also studying about the acceleration, displacement, speed of the body, then it will be termed as kinetics. So study of body, rigid body in motion, considering the forces causing the motion, will be termed as kinetics. So this is the basic classification of engineering mechanics. So in this course on engineering mechanics, we shall be learning about mechanical interaction between bodies. That is, we will learn how different bodies apply forces on one another and how they then balance to keep each other in equilibrium. This will be done in the first part of the course. So in the first part, we will be dealing with statics, and in the second part, we then will go to the motion of particles and see how does the motion of particle get affected when force is applied on them. So in the second part, we will be studying about dynamics. So let us now move on to some of the basic concepts required to study engineering mechanics. The basics of all solutions to mechanics problems are the Newton's law of motion. So let us first look into these three Newton's law of motion. The first law of motion states that a body at rest or uniform motion will continue to be at rest or uniform motion until and unless a net external force acts on it. So what does Newton's first law mean is, if I have an object at rest, it will stay at rest unless a net force is acted on it. And if an object is in motion, it will stay in motion unless a net force acts on it. So you have already studied about the Newton's law of motion in your physics classes, maybe in the 11th or 12th standard. Now I'm just brushing up what each of this law states, because that will be required in our course of engineering mechanics. Moving on to the next law, Newton's second law of motion. It states that the rate of change of momentum of a body is directly proportional to the applied force, and the change in momentum occurs in the direction of the applied force. So Newton's second law of motion gave us the expression for force, which states that force is equal to mass into acceleration. Let us now see how did we get the expression for force. As per Newton's second law, it states that rate of change of momentum of a body is directly proportional to the applied force. So I have written here, force is directly proportional to rate of change of momentum. P here indicates momentum. So let us simplify this. Force is directly proportional to, now what do you mean by momentum is nothing but mass into velocity. So change in momentum will be final momentum minus initial momentum. So final momentum is given by mass into the final velocity, which is denoted here as v, and initial momentum is mass into initial velocity, which is u. So change in momentum will be m into v minus m into u. M is the notation for mass. So if I simplify this further, we can take m common and you will get v minus u divided by t. Now v minus u is nothing but change in velocity. And what is change in velocity upon time? Change in velocity upon time is nothing but acceleration. So we are getting here the expression as force is directly proportional to mass into acceleration. To remove the proportionality sign, we have to replace that by a constant. So force is equal to K into M into A, where K is the constant of proportionality and the value of K comes out to be 1 when the values are taken in SI unit. Now what is the SI unit for force? The SI unit for force is Newton. So what is 1 Newton? 1 Newton is that force that is required to be applied on a body having mass of 1 kg, and because of that force of 1 Newton and mass of 1 kg, the body is moving by an acceleration of 1 meter per second square. So 1 Newton is the force required to move a mass of 1 kg by an acceleration of 1 meter per second square. So if I substitute the value of force as 1 Newton, mass as 1 kg and acceleration as 1 meter per second square, I will get the value of K as 1. Okay, just substitute F as 1, M as 1 and A as 1. You will get the value of K as equal to 1. So since K is equal to 1, finally I am getting the expression here for force. force is equal to mass into acceleration. So second law of motion gives us the expression for force, and from the expression we know that force is directly proportional to acceleration. So if I want to increase acceleration of any body, I have to increase the applied force. That we can see in this particular figure. You can see a person trying to move a mass. So he is applying certain force, and because of that force the mass is undergoing certain acceleration. Now if he wants to increase the acceleration, what he has to do is increase the force. So more the force, more will be the acceleration. So this is the diagram which shows you the application of Newton's second law of motion, and finally coming to Newton's third law of motion, which states that for every action there is an equal and opposite reaction. So consider a person using his finger applying force onto a wall. The wall in turn will apply equal force but opposite in direction onto the finger. So this is a picture which shows you the application of Newton's third law of motion, which states that every action has equal and opposite reaction. Moving on to system of units. The various type of unit system used are CGS system, FPS system, or it is also called as British system, MKS system, and the most common used around the world is SI system, or it is also called as System of International. These different systems of unit are most commonly used in science and engineering. The difference among them arise out of the differences in unit used to represent the fundamental quantities. The various fundamental quantities are length, mass, and time. In case of CGS system, the unit for length is expressed in centimeter, mass is expressed in gram, and time is expressed in seconds. So CGS stands for centimeter, gram, second system of units. Next is FPS system, where length is expressed in foot, mass is expressed in pound, and time is expressed in second. So it is foot, pound, second system of units. And the next one is MKS system, where length is expressed in meter, mass in kilogram, and time in second. So it is meter, kilogram, second system of units. Now let us see how SI system is different as compared to MKS system. In case of SI system, or it is also called as International System of Units, mass is expressed in kilogram, length is expressed in meter, and time is expressed in seconds. So if you see these three fundamental quantities, the units of mass, length, and time is same in case of SI as well as MKS system, but the unit for force in case of SI system is Newton, while in case of MKS system the unit for force is kg force. Now what is the difference between Newton and kg force is 1 Newton is the force required to give a mass of 1 kg and acceleration of 1 meter per second square. Now what do you mean by 1 kg force, which is the unit of force in MKS system? 1 kg force is the force required to move a mass of 1 kg by gravitational acceleration of 9.81 meter per second square. So in case of MKS system, the force is unit of force is kg force. And what is 1 kg force? 1 kg force is the force required to move a mass of 1 kg by gravitational acceleration of 9.81 meter per second square. Now what is the relation between 1 kg force and Newton is 1 kg force is equal to 9.81 Newton. So unit of force in SI is Newton. In MKS system, unit of force is kg force. In case of CGS system, the unit of force is dyne. In case of FPS system, the unit of force is pound force. And in case of MKS, as I have already said, unit of force is kg force.